Hello math learners, so for today's video we are going to proceed in properties of sampling distribution and sample mean. So we have parameter, so let us define what is parameter. A measure that describes a population or it measures the number of populations. It is usually denoted by Greek letters. So I'm not mistaken, you are already familiar what are the Greek letter. Yung mga alpha letters, beta, gamma, and the other Greek letters. Okay? Or the Greek letter U, such as it represents the mean. Ganun pa yung parameter daw. Statistics, when we say statistics, it measure that describes a sample, usually denoted by Roman letters. Now, in my last video, we already recap regarding to the mean, variance, and the standard deviation of the random variables. Same with, already discussed this in my in my previous videos. Okay. Now, in the mean of the random variables, how can you read this first? This read as the population mean of the sample mean of the sample distribution. So, mahaba. So, ganito na lang natin. The mean sub population mean sub sample mean. Okay. In population mean, this is it. The mean is equal to the summation of sample mean all over the number of population. Okay? Excuse me. In random variables, the variance is equal to the summation of the random variables minus mean quantity squared times the probability, such as the P of X. In population, we have the variance is equal to the X minus mean quantity squared all over N. Alternative formula, so we have the variance sub sample mean is equal to the summation of sample mean squared times the probability of sample mean minus the mean sub sample mean squared. So, ano kaya purpose ng alternative formula? Later on, we can find out what is the purpose. Standard deviation, so ganun lang. Katulad lang din siya ng variance, but in this case, square root. It is, in other words, it is the square root of variance. So, what is the purpose of alternative? Alternative formulas will be used for the following theorems in the next slide. So, next slide. Ito, yung slides ito. Next slide. Theorem 1. First theorem, if all possible random variable size are drawn with replacement. Ibig sabihin, pwedeng halimbawa, kung sa isang klase, sa recitation nyo, kahit natawag ka na ng teacher mo, pwede ka pang matawag ulit. Ganon lang din dito. From a finite population of size large N, or yun naman talagang denoted not, with the mean and standard deviation. Then for N, such as the sample, then for sample sufficiently large, the sampling distribution of the mean X will be approximately normally distributed with the mean the mean sub sample mean or the mean of this sample mean in sampling distribution and standard deviation here. The standard deviation sub sample mean is equal to standard deviation over square root of the sample, such as the square root of little n. In summary, if I'm going to summarize this theorem 1, that we will assure that the mean of the population mean of the sample mean in sample distribution is equal to population mean, and the standard deviation of the sample mean in sampling distribution is equal to population standard deviation all over square root of n. So, how can we apply this? So, Solve problem number 1. A random sample of size 2 are drawn with replacement from a finite population comprising the digit 1, 4, 7. So before that, can we determine first the number of populations and the number of sample? How can we find? So it's easy to indicate the number of samples since from the word sample itself, so such as 2. And then the population, ilan to? Sa dalawa, tatlo. To tatlo. Excuse me. So find the permutation tuloy. It's permutation. It's a typographical error. Ano? With replacement tayo, ano? So 3 permutated sige. 3 permutation of 3 taken 2 at a time. So with replacement, kasi kung without replacement, katulad lang din yun ng mga diniscuss nyo nung grade 10 kayo. But this time kasi with replacement. That the permutation, ito ngayon, and the population quantity, the sample. Where your sample is 2. So 3 times 3, since dalawa to 2. 3 times 3 is 9. So we have 9 possible samples. Construct the sampling distribution X. 1, 4, and 7. Samples and the mean. 1 and 1. Why 1 we considered as mean? Because 1 plus 1, we are going to find the mean. 1 plus 1, hindi 11. 2. So 2 divided by 2, 1. 4 plus 4, 8. Divided by 2, 4. Dito na tayo dito tayo babase. No? Dito, ha? Next. Ito, makikita nyo may replacement. O yung 1, kinuha pa natin ulit. Yung 4, meron na tayong 4, kinuha pa natin ulit. O, ganun din sa 7. So, with replacement kasi. So, 7 plus 7 is 14. Divided by 2 is 7. 1 plus 4 is 5. Divided by 2 is 2.5. 1 plus 7 is 8. Divided by 2 is 4. 4 plus 7 is 11. Divided by 2 is 5.5. 4 plus 1 is 5. So, ito, di ba meron tayong 1 and 4? O, binalig lang natin ulit with replacement. 4 plus 1 is 5. Divided by 2 is 2.5. 7 plus 1, o, tingnan nyo. Yung 7 nyo, o, yung 1 and 7 meron na tayo, pero gumamit pa tayo ulit. 7 plus 1 is 8. Divided by 2 is 4. And 7 times. 7 plus 4 is 11. Divided by 2 is 5.5. Right? Even, although meron tayong 4 and 7, kumuha pa tayo ulit. Okay. Now, how can we verify? So, una, ay inarrange natin to. Yung mga naging given natin. 1, 2.5, 4, 5.5, and 7. So, balik tayo dito. Ilan ang ilang 1 meron tayo? Isa. Ilang 4 meron tayo? 3. 2.5. Ilan meron tayo? 2. Ilan meron tayong 5.5? 2. Ilan lang 7 natin? Isa. Okay, tandaan ng mga bilang. Kasi yan ay i-apply natin sa frequency. So, this is your excess, the sample mean. And this is your frequency. Ilang beses siya na ulit. So, tama lang naman kanina yung ano natin. So, these are the frequency. In probability distribution, so, ilan ba lahat ang sample natin? So, kung i-add nyo lahat ng frequency, 1 plus 2, 3 plus 3, 6 plus 2, 8 plus 1, 9. So, 9. Out of 9. So, kung i-add nyo yan lahat, 1 ang magiging sagot yan. 9 over 9 or 1. So, una, ang ano natin dito, we are going to verify that the population mean of the sample mean is equal to the population mean. Is equal to each other. We have some formulas, di ba? Ngayon, ito. Ang ginawa po natin dito, the x times the probability. So, ngayon, kung i-add nyo lahat yan, ito lang din ang sagot. Population mean here. So, add nyo lahat tong x's na to. Then, divided by the number of populations such as 5. Ilan ba ito lahat? Ilan ba ito lahat? 5. So, 20 divided by 5 is equal to 4. Ganito, kapag meron kayong nakita na magkaiba ang sagot dito, isa lang pala ang ibig sabihin niya. May mali sa computation mo. Or maaaring may mali ka din dito sa paglalagay mo ng samples. So you can go into back to 0. Kaya please be careful sa paghahanap ng samples. So proven that the population mean of the sample mean is equal to population mean. Second one, diretsahan na tayo sa standard deviation, no? Hindi natin hanapin yung variance. Hanapin pa rin naman natin yung variance, but diretso na tayo sa standard deviation. So, ayan, minultiply natin. So, diretsahan ko na siya. Your mean is 4. So, ngayon, next. Ito ay natin to ng alternative. 1 times 1 is 1. 2.5 squared is equal to 6.25. 4 times 4 is equal to 16. 5.5 times 5.5 is equal to 30.25. 7 times 7 is 49. Gagi, sakit na lalamunan ko. Okay, going back. So, we have the squared values of the sample mean will be multiplied to probability distribution. So, 1 times 1 over 9, 6.25 times 2 over 9, 16 times 3, and we have 30.25 times 2, and next we have 49 times 1 over 9 is okay. So, syempre, sasabayan niyo rin ako. Okay. Tapos wala sumabay, no? Okay. So, if you're going to add all of this, this will be equal to 19. Try it using your calculator. Using alternative formula, so we have the square root of the summation of the square root of the sample means times the probability distributions minus the square of the population mean of the sample mean. Here, so where the mean is 4 times 4 is 16, then 19. So substitute nyo lang. 19 minus 6 square root of 3 is equal to 1.73. Using the standard formula here, ngayon nakikita nyo magkaibang sagot. 2.45. So, dito na natin may papakita ngayon kung totoo ba si Theorem number 1. Now, ito na i-prove nyo. Where the standard deviation of the sample means is equal to 1.73 and the standard deviation of the population standard deviation is equal to 2.45. So then substitute where the standard deviation here, and then where the sample is equal to 2. Okay, makita yung square root. Then, using your calculator, ito lang din yung makukuha. So, tama lang. So, this is, we already proved that the population standard deviation of the sample mean is equal to the population standard deviation all over the square root of the sample. In other words, Theorem 1 proved correct. Next, Theorem 2. If all possible, so ito ay, what we call this? Ito naman ay without replacement. Without. Ibig sabihin, walang replacement na magaganap. From a finite population of size n with the mean and standard deviation, then the sampling distribution of mean x will be approximately normally distributed with the mean and standard deviation given by the summary on the right side. Ito yun. So, same with, we are going to prove that this is correct. But in this case, ito naman. The standard deviation of the sample mean is equal to the standard deviation or population standard deviation over square root of the sample times the square root of population minus sample all over population minus 1. Sakit sa ulo, no? Solve problem number 2. So, in this case, ginamit lang po natin yung example sa solve problem number 1, but in this case, walang replacement, without. So, we are going to verify the theorem 2. So, we already find the mean and the standard deviation. So, combination, so, yung n nyo ay yung 3. So, then yung inyong little n is 2 or sample. Computin nyo sa calculator. So, ito yung resulting samples. Pero in computation, 3 minus 2 is 1 factorial. Or if you're going to simplify, that is only 1. And 2 factorial. So, kung aalisin nyo, di ba 3 times 2 times 2 times 1, 2 times 1, alisin nyo itong factorial sa 3. 3 divided by 1. 1 factorial is equal to 1. 3 divided by 1, 3. So, tama lang yung computation natin, di ba? Construct the sampling distribution X. So, 1, 4, 7 samples. So, tatlo lang. Kasi, tatlo lang naman sila. Then, dalawa lang naman na samples. 1, 4, 1, 4, 7, and 1, 7. So, wala naman tayong babalik na rin. So, walang replacement. So, nagamit na natin yung 1 dito sa na to. Hindi natin. Okay. Hindi natin yung position. So, ngayon, we are going to verify. So, una, yung sample means natin niya, frequency, tig-isa lang naman. Then, sinortcut ko na pala, since tatlo, diba? So, add nyo yan, 1 naman ang lalabas. X time the sample mean times the probability distribution. So, multiply natin. Yung mean nyo is 4. Na-try na po natin yan. We already proved that. Parasang naman, di ba? Now, standard deviation using alternative formula. So, ito yung lumabas. So, kagaya lang ginawa natin. Pero ginawa ko dito ay shortcut ko siya. Wala kayo nakitang x squared sa katabi nito. So, squared nyo siya, times nyo dito. Squared nyo din to, times nyo dito. Ganun lang. Squared of 5.5, 30.25 times 1/3. Ganun. Okay, 17.5. So, since kahit i-add nyo yan, ito rin naman ang lalabas. 17.5 minus 16. Since squared ng 4 niya is 16. So, we have 1.225. So, your variance is 1.5. Nakalimutan kong i-explain. Di ba nakuha nyo ito? Bago nyo hanapin yung square, ito na yung variance nyo. Square root nyo to, ito na yung standard deviation. Using standard formula here, so, saan po natin ito nakuha? Ito lang naman yon. 1 minus 4 squared. So, let's shortcutin na 3. 0 squared, 0. 3 squared, 9. So, add nyo square root of 6. Ito lang naman din yun eh. Now, ito na yung final natin. We are going to verify this. Now, where the standard deviation of the sample mean is 1.225 and the population standard deviation is 2.45. Where your sample is 2 and then your population is 3. Substitute. So we have, ito ngayon. Dapat mag-i-equal siya dito. Yun ang target natin. Kapag yung equal ba? So gamit nga tayo ng calculator. Try this. At this big of at 5 seconds. Okay, tingnan nga natin kung lumabas yung result. Ito ba ang lumabas sa calculator nyo? So, comment below lang. Na, so we already proven that the standard deviation of the sample mean is equal to this. Babasahin ko pa eh. Tingnan nyo yung oras natin. 20 minutes na, no? In other words, Theorem 2 is proved correct. Now, this will be discussed in my next video. Separated ko siya. It is also called central limit theorem. Okay? So, see you in my next video.